Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will discuss question 1, 2 and 3 from March 2021, paper 2. Part A is simply asking us to complete table 1.1 by writing vector or scalar in front of these given quantities. Acceleration is a vector quantity because acceleration is equal to rate of change of velocity, and velocity is a vector quantity. Power is a scalar quantity because power is rate of transfer of energy. Any form of energy is a scalar. Power is also scalar. Work is also scalar quantity because work is a way of transfer energy. Means simply is a way to transfer energy from one object to another object without rise in temperature. So work is also scalar quantity. For part B, we need to determine the acceleration of the object from time t is equal to 0 to time t is equal to 4.0 seconds. And for this question, velocity versus time graph is given. Velocity is on y-axis and time is on x-axis. So acceleration is simply equal to the gradient of vt graph. Simply is equal to gradient of vt graph. As the question is asking us, we need to find acceleration from time t is equal to 0 to time t is equal to 4.0 seconds. So we need to find the gradient of this line. We need to find out. First of all, let's try to write down the coordinates of these 2 points. If you look at this point, coordinates of this point are 0, 0.70. If you look at this point, x coordinate is 4.0 and the y coordinate is 1.40. Now we have coordinates, simply we can find out gradient. Gradient simply y2 minus y1 over x2 minus x1. So y2 in this case is 1.0 and the y1 is 0.70 divided by t2 minus t1, and t2 is 4.0 minus 0.0. If we solve this one, our final answer is 0.18 meters per second per second. This is our final answer. For the second part, we need to determine the distance moved by the object from t is equal to 0 to t is equal to 4 seconds. And velocity versus time graph is given to us. It simply means that we need to find the area under this line. We have already found y coordinate, that was 1.40. Now we need to find the distance. We simply need to find this area, and this is a trapezium. So area of trapezium, simply we can write down this is 1.40 plus 0.70 divided by 2, and we need to multiply with time, 4.0. And if we solve this one, our final answer is 4.2 meters. So we can write down our final answer here. Part C1 is asking us to define force, and force we can simply define as rate of change of momentum. For part C2, it is given to us that the motion represented in figure 1.1 is caused by a resultant force F acting on the object. Question is asking us on figure 1.2, we need to sketch the variation of F with time t from t is equal to 0 to t is equal to 12 seconds, and numerical values of force are not required. If we look at figure 1.2, on y-axis we have force, and this is the resultant force. And if the mass is constant, resultant force simply F is equal to ma. The resultant force and acceleration, they always have same direction. So these are two quantities in physics. They always have same direction. So this is very important. Same direction means that when resultant force, this is positive, mean this is acting in positive direction, acceleration will be positive. When direction of resultant force is negative, acceleration also will be negative. This is what we need to understand. Now let's try to find out when acceleration is constant, when acceleration is positive, when acceleration is negative, and when acceleration is zero. If we simply look at this velocity versus time graph, velocity is on y-axis and time is on x-axis. Simply we need to find the gradient. If we look at this gradient, means from this point to this point, this gradient is constant and this gradient is positive. So it simply means that acceleration is constant and acceleration is positive. So we can also say in this case force is positive and force means the resultant force is also constant. If we look at the second part, in this case we can simply find out that acceleration is zero because the gradient of this line is zero. So we can also say that resultant force is zero between time t is equal to 4 seconds and t is equal to 8 seconds. That if we look at t is equal to 8 seconds to t is equal to 12 seconds, we can simply find out that gradient of this line, this is negative, so acceleration is also negative. But the gradient of this line is constant, so acceleration is constant, so force is also negative and force is constant. This is how we can sketch force versus time graph, but one thing we have to be careful is that the value of the force here means the resultant force acting between time t is equal to 0 to t is equal to 4 seconds has to be smaller than the force acting between t is equal to 8 to t is equal to 12 seconds, because the gradient of this line is steeper than the gradient of this line. Let me write down here, let's say this force is F1 and let's say this force is F2. So F2 has to be greater than F1. For the second question, part A is asking us, we need to state what is meant by work done. Work done simply is equal to force times distance moved in direction of force, or simply we can say product of force and distance moved in direction of force. This is how you can write your final answer. For part B, it is given to us that a ball is released from a balcony at the top of a tall building and the ball falls vertically from rest. Means the initial velocity of the ball is equal to 0 and finally ball reaches a terminal velocity. And the change in gravitational potential energy is given. This is equal to 60 joules and the ball hits the ground and kinetic energy of the ball when it hits the ground is 23 joules. First of all, let's sketch this problem so you can see the clear picture what is happening. It is given to us that the initial velocity of the ball is 0, so we can simply write down u is equal to 0. And it is also given to us that the gravitational potential energy of the ball decreases by 60 joules. If we take at this point gravitational potential energy of the ball is equal to 0 joules, then we can say that initial value of gravitational potential energy, this is equal to 60 joules. It is also given to us that the ball reaches a terminal velocity. We can write down Vt, and the value of Vt is given, that is 16 meters per second. And it is also given to us when the ball hits the ground, it hits the ground with velocity that is equal to terminal velocity. Velocity has magnitude 16 meters per second. And kinetic energy at this point is also given, that is equal to 23 joules. Question is asking us, we need to find the mass of the ball, and that mass has to be equal to 0.18 kgs. So this is very straightforward question if you understand this problem. Simply we need to use concept of kinetic energy and we can find the value of mass, because kinetic energy is given and the speed is given. So in this case mass is simply is equal to 2 times kinetic energy divided by v square, and we have all these values. We simply need to plug in to find the value of mass. So if we solve this one, our final answer will be 0.18 kg, and this is the mass of the ball. Question was asking us show that, so this is our answer. Second part is asking us to calculate the height of the balcony above the ground, but for this question change in gravitational potential energy is given, that is equal to 60 joules. Simply we need to find the change in height. So the change in height is equal to change in gravitational potential energy divided by force of gravity. In this case, change in gravitational potential energy is 60 and the mass of the ball is 0.18 and value of G is 9.81. If we solve this one, we can find the change in height. In this case, change in height is 33.9 meters, or we can say is equal to 34 meters up to 2 SF. Because the least number of significant figures in raw data we have 2, so our answer has to be up to 2 SF. So the final answer is 34 meters. Let's move on to third part. Third part is asking us to calculate the average resistive force acting on the ball. For this concept, we need to use law of conservation of energy. In this case, the work done by resistive forces is equal to change in mechanical energy, means the change in gravitational potential energy minus the change in kinetic energy. Change in gravitational potential energy is equal to 60 and change in kinetic energy, in this case work done by resistive forces, this is equal to 37 joules. Now we have work done by resistive forces, so we can calculate the average resistive force acting on the ball. And work done by resistive forces is equal to resistive force means the average resistive force times the distance, and this is equal to 37. So we can write down average resistive force is equal to 37 by 34 because this is the distance traveled by ball. So if we solve for this, our final answer will be 1.1 newtons. So this is magnitude of average resistive force. Part C is asking us to state and explain the variation, if any, in the magnitude of the acceleration during the time interval when the ball is moving downwards but before it reaches constant terminal velocity. Let's try to understand this one with the help of this simple sketch. At the beginning, it was given to us that the ball has zero velocity and the force acting on the ball at this point is only force of gravity. Now, as the ball is moving down, the resistive forces will increase. So you can see here, as the ball is moving down and the speed of the ball is increasing, so the resistive forces are also increasing, but the magnitude of force of gravity is not changing. So this we can say is resistive force. If we write down our resultant force at this point, F net will be equal to mg. That if we write down net force at this point, net force will be equal to mg minus resistive force. If we go to the final point, when the ball has reached terminal velocity, at that point you will see that the forces are balanced, or we can simply say at this point mg is equal to Fr and the resultant force at this point will be 0. Now if we go from point 1 to second point and then we go to third point, means the third position, if we go to this, you can simply see that resultant force is decreasing. Resultant force is decreasing, it simply means that acceleration is also decreasing because resultant force is decreasing. So the first part question is asking us state, so we can write down magnitude of acceleration decreases. So 1 point you can write down state magnitude of acceleration decreases. Now the question is also asking us, we need to explain, so we can simply explain that as the ball is falling, weight is constant, weight remains constant. We can simply say weight remains constant. So second point you can write down weight remains constant and resistive force means Fr is increasing with speed, so this is the second point we can write down. And the third point we can say that F net decreases. F net decreases because Fr increases with speed. So that's all what you need to write down. If you write down these 3 points, you will get 3 marks. For our third question, it is given to us that a spring is extended by a force and the variation with extension of the force is shown in figure 3.1. It simply means on y-axis we have force, this is the force applied, and on x-axis extension, and extension is given in centimeters. Question is asking us state the name of the law that relates force and extension of the spring. Very simple question. So that law is simply Hooke's law. So this is how you can write your answer for this. For part B1, question is asking us to calculate spring constant and our answer has to be newtons per meter, and force against extension graph is given to us. It simply means that K in this case is equal to the gradient of Fx graph is equal to gradient of force versus extension graph. Simply we have to find the gradient. In order to find gradient, we can take 2 points on this line. Let's say we take this point and we take another point here. This is our second point. Let's write down the coordinates of this point. So coordinates of this point are 5.0, 7.0. Now we can find the gradient, that is equal to 7.0 minus 0 divided by 5.0 minus 0, but this is in centimeters, so we have to multiply with 10 to negative 2. If we solve this, our final answer will be 140 newtons per meter. So this is our final answer. Let's move on to second part. Second part is asking us to calculate the strain energy in the spring when the extension is 4 centimeters. Means when the extension is 4 centimeters. So for this one, simply we need to find this area, or we can use formula. Let me use the formula. You can also check with area later by yourself. Elastic tension energy in this case is 1/2 kx square. We have the value of k we have just calculated. This is 140 newtons per meter, and extension is given, this is 4 centimeters, so we have to convert into meters. Now if we take the square of that, we can find out value of EPE, means the value of strain energy, and in this case that is equal to 0.11 joules. For part C, it is given to us that now one end of the spring is attached to a fixed point, as you can see here is attached to the fixed point. But one thing you need to be very clear is that this is the same spring, the one we have studied in part A and part B. And the other end of this spring is attached to a cylinder, and the cylinder is submerged in a liquid. So this is the other end of the spring. But it is also given to us that extension in the spring is 4.0 centimeters. As the extension is 4.0 centimeters, so we can find the value of the spring force. So value of spring force we can find from here, and this value is equal to 5.6 Newton. So this is important. So this is value of the force when extension is 4.0 centimeters. Now question is simply asking us, we need to find the upthrust on the cylinder. 0.60 Newton means simply we need to show that. First of all, let's try to understand the forces acting on this cylinder. The one force acting on this cylinder downwards, this force is weight, and there are two forces acting on the cylinder upwards. One force is the spring force, we can say this is Fs, and the other force acting on this cylinder is upthrust, so this is upthrust. So this is free body diagram for the cylinder. Simply we can write down, in this case, as the cylinder is in equilibrium, it means upward forces has to be equal to downward forces. Downward force is weight in this case, and upward force is upthrust and spring force. Upthrust plus spring force. In this case, value of the weight is given, that is 6.20. Value of upthrust is not given to us, but the spring force we have found, that is 5.6. Now if we solve this one for upthrust, we can find out its magnitude. In this case, the value of upthrust is 0.6 0.60 newtons. For second part, we need to calculate the difference in pressure between the bottom face and the top face. Mean between this face and this face, we need to find the value of delta P. For this question, we have already calculated upthrust, and upthrust is simply equal to delta P times cross-sectional area. Means the cross-sectional area of this cylinder. Upthrust we have already calculated, that is 0.60 newtons, and delta P we need to find out. Cross-sectional area is also given, that is 1.2 times 10 to negative 3 meters squared. Now delta P is quite straightforward one. If you simply divide upthrust by cross-sectional area, we can find out value of delta P. In this case, delta P will be equal to 500 Pascal. So this is our answer. For third part, we need to calculate the density of the liquid, but in the second part we have already calculated delta P, so we can write down delta P is equal to rho G delta H. This question is asking us to calculate density. We can write down density will be equal to delta P divided by G times delta H. Delta P we have already calculated, that was equal to 500 Pascal. So value of G we can use is 9.81 and delta H is given here. This is equal to 5.8 centimeters, so we can convert into meters, so we need to multiply by 10 to negative 2. Now we can solve for density of the liquid. If we solve this one, density of the liquid is 879 kgs per cubic meter. So this is our answer for this part. For part D, it is given to us that liquid in part C is replaced by another liquid of greater density. We need to state the effect, if any, of this change on the upthrust acting on the cylinder. First of all, let's try to understand what is upthrust. Upthrust is simply equal to weight of fluid displaced. Weight of fluid displaced. Simply we can write down this is equal to rho G times V. Rho in this case is the density of the fluid and V is the volume of the cylinder. V is volume of the cylinder. So if density of the fluid increase, it simply means that upthrust will increase. So we can simply write down in this case upthrust will increase if density of the fluid increases. And the second one is asking us what is effect of that on extension of the spring. If we look at the forces acting on this cylinder, we have already discussed that point, that forces acting on the cylinder are weight, and weight is acting down, and this cylinder is in equilibrium, means the forces are balanced. Upthrust is the force that is acting upward, and there is spring force that is also acting up. Spring force is also acting up. But in this case, weight of the cylinder, this is not weight of the fluid, this is weight of the cylinder. This is constant, this is not changing. Now if the upthrust increases, so the spring force has to decrease. If the spring force decreases, then it simply means extension in the spring that will also decrease. So simply you can write down extension of the spring decreases in this case.